We want to build a home that is morally defensible. We take every opportunity with any moment to make a decision that we have to at least pause and reflect and say, is this the best we can do right now?
Welcome to the Passive House Podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House Podcast. Welcome back to the Passive House Podcast. I'm Matthew Cutler, coming to you from Auckland, New Zealand, and I'm joined this week by Zach Semke in Seattle. How you doing, Zach?
I'm doing well. Just drying out from our crazy atmospheric river over the last couple of weeks.
It's been a bit wet there. Yeah,
it has been. It has been soggy.
Very soggy. And also Jay Fox, good to have you back on the pod this week.
Yeah, fantastic to be here again.
And we've got a great interview that you and Ilka did to bring the audience this week. Was really enjoyed listening to Ben Bogie. Unfortunately, Ilka can't be with us for the session today, but really great to have her and her questions and insights on that pod. So we'll get into that. But before we do, we've got a few people to thank. Zach?
We do indeed. So a big thank you to LG Air Conditioning Technologies for being our sponsor of the week this week and making all of our programming possible here at Passive House Accelerator. And also a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. And thanks to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Thacro, Icon Windows and Doors, Intelligent Membranes, LG Air Conditioning Technologies, and Source 2050.
Awesome. All right. Well, Ben Bogie, I think a few people have heard of him because he has been pretty active in the space, as he explains, and I think you do quite a good job of introducing him, Jay, and his background. So let's jump in, and we'll catch you after this interview.
Hello, my name is Jay Fox. I'm a co-host here with Ilka Cassidy for the Passive House Podcast. Today, our guest is Ben Bogie. Ben comes from a long line of high-performance builders, and you've probably seen him on Green Building Advisor and Fine Home Building. He is also the Director of Outreach and Education and Production Manager for BPC Green Builders. Ben, thank you so much for sitting down with us.
My pleasure.
Great. Well, our first question, speaking of, coming from a long line of builders, what were some of the early lessons that you learned and that you continue to think of as being foundational to your work?
Okay, so I guess to add a little bit of context here before I address that is I have a rather uncommon distinction in that I'm a third generation builder. I'm also a third generation high performance builder, which I have yet to meet another one. If anybody knows them, please let me know because we can exchange phone numbers and commiserate. But my grandfather and father were both builders and started building super insulated, airtight, thermally broken buildings back in late 1970s after the Arab oil embargo. Some of their work was monitored by local utilities back then to establish whether or not these types of building methodologies were feasible for mass adoption in efforts for them to help curb energy consumption because everybody was thinking about it at that time. So I grew up with things like thermal bridging and air tightness and reducing framing as just how I was taught as I came into the industry. I was a pretty crummy high school student, so I dropped out in my freshman year and went to work cleaning job sites and literally worked my way right up through there. And during those, I was being handed down things from my father, regardless if I wanted to listen or not, about things like thermal bridging and about air tightness and about proper flashing techniques. And so those are kind of the things that I trend back to, is like the silly things like, don't put that extra 2x under the end of the sill. It's not doing anything there but taking up space that could be insulation, right? Those core little tidbits have stuck with me. And they were kind of some of the early things that, as I got out later in my career and started to look at other builders and meet with other builders, that I started to identify weren't common across the rest of the industry. And I had no idea, like that was just the way we did things, right? So it's put me kind of in this position that I am now, where I do a lot of education because my pump was primed early, so to speak.
Cool. And what like location or what state was this happening in?
Yeah, this is Connecticut. Most of our work has always been Connecticut, over into New York. I've done some work up into Massachusetts, and total like clarity here, it hasn't always been high performance work. They did that work in the early 80s, and then energy costs dropped and nobody cared about this stuff anymore. But we still practice it, maybe not to the degree if it was being supported and funded by people at that point, but we were still practicing sound building science techniques and continuing to learn and evolve. Doing a lot of historical work, a lot of renovation work, understanding how buildings fail and fall apart in the New England area. Also, then getting to see like historic vernacular stuff and like, well, how come that thing's been around for 300 years and that thing routes in 5 years, and starting to, just experientially draw those connections.
Well, it's pretty amazing. Third generation. Congrats, and I'm sorry.
I had a shop teacher. My shop teacher in middle school and early high school said, "Yeah, you're really good at this. You should consider a career in this." And I said, "Absolutely not. There's not a chance. I've seen my whole family do this, but here I am."
Well, yeah, here you are. So I'm actually curious, because high performance building has changed for sure over the last 3 generations, right?
Mhm.
In the beginning, there was all about foam, packing these buildings into basically a foam box, and then
Well, it's even like our family's assemblies history goes to prior to foam. It was a
Okay.
lot of like early Canadian and Scandinavian informed stuff. A lot of work coming out of Minnesota at that time. I'm pretty sure that one of the genesis moments for my grandfather in really adopting this was seeing Harold Orr's Resource Conservation House, right? Like that work, he was tuned in and watching those things develop at that time. So it was even pre-foam. This was back when they were doing like essentially a Larson truss with a polyethylene vapor at 1/3, 2/3 inside of them, and then just packing the thing full of fiberglass. Double pane aluminum windows was like the crazy thing. They were just like a giant heat sink through the openings, but they thought they were great at the time. It was what they had. So yeah, it's been cool to kind of like watch the evolution to where we are now.
Yeah. That was actually going to be my question. What, like, walk us through the evolution a little bit. I mean, I'm really curious where it started for you, and the lessons that you learned and where you are now.
Yeah, those were I collect some of the old books that are my father's and grandfather's, and I like to collect other old books to learn from, because there's a lot of great information there. And there was like this is funny, I'm just realizing this. I largely build the same way that they did. Our go-to assemblies, and there's mixed emotions around these assemblies, which we can talk about in a building science lens later, is a double stud wall, right? It's a very cost-effective and well-performing wall system when it's done correctly. And that's essentially what they were doing back there in the 1970s. That's one of the speaking engagements that I give frequently, is a history of building science and history of building performance. And if we go back to some of that very early work coming out of like even MIT in the 1930s, and the work that they did for developing building efficiency and novel HVAC systems and stuff like that. A lot of those systems that were deployed were double stud walls. It was just a natural progression. And it's where I still am today. It has changed, right? They're not full of fiberglass and polyethylene as they were back in the day, unless we're building at McMurdo Station or something like that, where we need polyethylene. But it's largely the same kind of overall assemblies. Places that have really changed were roof assemblies. Our roof assemblies are much better now than what they had historically, which is cool to see. Roofs excite me. It's where I get really into talking about it because there's so much building science that's going on there. It's such a critical part of the envelope. So I think roof assemblies is where I've seen a lot of evolution in recent years. It's crazy to see the pace at which we're progressing as well. As somebody who has the vantage point of having watched this over, more than 4 decades now in some way, we've changed a lot. And I think we lose sight of that. And I think it's important to have that moment of reflection and realize how far we actually have come.
And I'm curious with like specifically like insulating material, what shift have you seen in, I guess, more conventional built? I spend way too much time in my life in the high performance sphere, and I like don't even know what's happening in normie land. Like
it's all changing. It's all changing, and it's incredible. Like when I put a tool belt on for the first time and started collecting a paycheck, not just carrying lumber for dad on the weekends. When I actually started working in the industry in the late 90s, everybody knew how to do the same thing. It was 2x4, 16-inch on center. You stapled up the Tyvek, you made the X cut in the Tyvek, you folded it into the opening, and you put in the Anderson 400 series. Right? That was like, you could take a carpenter from anywhere in the country and say, we're building a house, and they essentially know how to do it. That is not the case in the slightest. You can take a carpenter from the job site next door and move them over, and they'll be lost. Like they might have some touch points of reference, but overall, like the systems and the component stacks and the material types and interactions are so tuned on projects, whether it's by performance or whether it's just because that's what their vendor carries.
Yeah, it's super interesting.
And I just thought of there's a guy, what's his name? Randall the Inspector, who's like social media guy, and he goes around and just points out all of the horrible work that's being done. And yeah, I don't really have a follow-up. I'm just thinking about how, kind of piss poor some of the things that are on conventional job sites look these days. And that anybody who's doing that type of work would totally be lost on a passive house project.
It doesn't even have to be a passive house project. It can just be a decent project. Yep.
But you're actually giving your best to educate builders, right? Especially with high performance. And that's where we actually got to spend some time together, was at the International Builder Show where was that, in Florida, right?
Orlando. Yeah, we're going back there in a little over 2 months, something like that, for Orlando again. Yep.
Yeah. So you're really crucial for building up this high performance kind of corner within that giant conference or convention. So I mean, that's really great that you're doing that. How is that working? Like how do people, conventional builders, come to you, and how do you really go about educating them, and has it been successful?
Well, first off, I'm humbled to sit in an educational position in the industry, and just to put into scope. So at the International Builders Show, what we run is, it's called the Construction Performance Zone, and it is the largest educational venue at the entire show. And I get to work closely with Travis Brungart and Joe Cook from Catalyst Construction, KCBS, and Beer Building Science Symposium on designing the content there. And it's pushed towards high performance, right? We can't push all the way into the crazy world that my day job may live in, but we're pushing sound, well-founded, market scalable solutions to help people make buildings better, right? And ultimately, it's well received. They keep having us back. The sponsors are happy, and the seats are full, which shows me that in the lens of the conventional builder or the broader home builder industry, people are hungry for this information. People want to do better. They just need somebody to explain it to them, the why we do it this way and the how we do it this way, and then they take it and they do it. It's like, for me, like I said, it's humbling to be able to sit there in front of several hundred people all day long and see just a steady churn of people that are interested in asking really good questions and asking really tough questions about how we can bring these things to broader adoption. And it's happening. I mean, we think about, like, in a lot of ways, and I'm vocal with them about this, the NAHB at times has felt like it has run counter towards the things that are important to me around performance. But I don't think that's actually true. I think those are isolated moments. Overall, they have a prerogative to just lift the industry, and they see the direction we are headed. The industry sees the direction we are headed. Manufacturers see the direction we're headed. Investment firms, private equity sees the direction we're headed. It's towards more high performance. It's towards electrification. It's towards decarbonization. It's towards biogenic materials. And some of us sure are out there pushing at the tip of that spear, but the rest of the spear is right behind us, and it's coming along. So it's incredible to be a part of and see.
So where do you see the biggest change, like in terms of where high performance or better building is going? Is that the availability of, for example, windows or materials, or is that more the awareness, even with embodied carbon, using more natural materials, or where do you see the shift?
I think it's both. I think, we had a kind of like oh shoot moment not too long ago when we realized that the energy code and the building code in our area was an R60 roof assembly, which has now been rolled back a little bit. But that was like the domain that we lived in, and everybody thought we were insane for a long time. Right. I remember when I did my first fully exterior insulated houses back 2010 or something like that, where we wrapped the whole thing in polyiso, and everybody in the local community thought I was insane. The lumberyard was like, oh, the crazy hippie's wrapping that whole house in foam. What's he doing? But now, like, that's part of the code in our area right now. So it's to see that shifting, and that means that those material flow streams are there, right? Because it's in the code. So that means people have access to continuous insulation. They have access to rain screen systems and products. They have access to better flashing materials. They have access to, the new energy code is going to push us in our climate zones to a 0.2 U value window, which forces people into triple glaze. I don't mean to say forces, because I don't want to feel like that, but like, that's incredible. That means that any manufacturer who wants to sell windows in our climate zone, which is going to be most of them, has to deploy a triple glaze system in their windows. Like, it's happening so quick, and it's also kind of scary how quickly it's happening, because there's a lot of risk in there if we don't get it right.
Yeah, for sure.
I guess for people, I'm originally from Michigan, and I speak with some of my friends who are in construction there, and building codes are a little, let's say, behind. I'll be polite. I think like the first multi-family passive house is being completed right now, or was very recently completed. If you're like getting your start, you want to get into high performance. I have literally 3 friends I'm thinking of. Shout out to Johnny, Liam, and Mike if you're listening. If they're just starting to get into high performance, like what resources would you say to go to? Like, what's your first? You're a good builder. You've done it for a while, but like, where do you go to like kind of learn about high performance? What would be your go-to places?
Buildingscience.com, first stop, and just pick a white paper and read it and watch your head explode. And then realize that there's like 4,700 more papers there that are free for you to do that again and again and again with. The Green Building Advisor is another one. Journal of Light Construction, Fine Home Building, Building America program, any of the work that comes out of Oak Ridge National Labs or NREL. These are all, those are publicly funded groups, resource groups that have done an incredible amount of work for decades and decades and decades around high performance building and have incredible resources that people neglect to look at. Places like that, going to trade shows is incredibly informative. Because it humanizes the learning. You get to stand next to somebody else that's maybe asking the same questions as you or dealing with the same struggles that you are. And you get to like, oh, shoot, I did one of those on our project. You want to give me a call about it? Oh yeah, I see that you did one of those. Like, it seems so trivial, but it is so incredibly important for people that want to get into this because you need to have a support network. You need to have people to lean on. YouTube is great, but you can't ask it, AI, you can ask a question, who knows how well it comes out. But like you need that interaction in order to like take that learning in and really embody it. And because we're talking about like fundamentally, this is how people feed their families, right? This is their business, this is their means of income. And it has to be something that you trust is not going to come back and bite you and you're going to be able to keeping able to put food on the table, right? That's what we're after here. So that's a really useful one. All the podcasts, oh my God, you guys, and everything that's out there, the rate at which we can get information about this stuff right now is daunting, which leads me to a point, which is it does seem very daunting for many at a time. And my suggestion there is just pick one thing on a project and try and make that one thing better, and then pick something on the next one. Because then after a little while, all of a sudden you've got this whole bag of tricks that you've figured out that now just come along as part of the course.
Yeah. And I think that's actually a good point, talking about being overwhelmed or things being daunting. You talk a lot. I mean, basically, you are kind of spearheading really, high performance and cutting edge construction, but you're also talking about educating the conventional builders, and you're talking about homes that are, I guess I'm quoting, morally defensible, right? So, or good enough. So how do you define that? Because I think that's a really good starting point, right? You want to build something that you feel good about, but maybe is not right there with certified passive house buildings, for example.
Or living building challenge or something like that. Like these very aspirational systems.
Yeah. So how do you define a morally defensible home for you?
Well, let me add a little backstory to that, and I'll be sharing this with them. We had a client come to us a couple of years ago, and we're in the process of building their new home right now. And these two clients were the most well-prepared clients I've ever seen in my life. They came to us with like a 40-page project briefing about what they're hoping to do and achieve and any of the supporting context around it and resources, which was like, oh my God, I'm screwed. These people are better prepared to build their house than I am. But one of the first tenets that they laid out to us in this project, and this is a unicorn project, they said, we want to build a home that is morally defensible. And I said, okay, what does that mean? And what I figured out it means throughout the process here is that we take every opportunity with any moment to make a decision that we have to at least pause and reflect and say, is this the best we can do right now? And it doesn't mean that we ultimately go for the best thing, but we identify when there are options and we discuss them, so that everybody has buy-in. And it's not like, oh, we spray foamed the thing because we needed to do the thing. What do you mean there was another way to do it, right? We don't want to have any of those options. And it's down to, one of the reasons that they came to my company, Building Performance Cooperative, BPC Green Builders, is that we're a worker-owned cooperative company, and they want to support what they think are resilient business structures in communities and support that initiative. We are practicing like old school, just sustainable basics, like local materials, like the siding is Eastern hemlock from, 160 miles away or something like that. And just trying to do all of the things that we know. and maybe overturn some stones in the process and learn some things along the way, which we also have.
Nice. And did you make use of like some reclaimed materials? I would think that that would be kind of a part of that framework.
I'm on the accelerator. I think it's next week on Project Spotlight, where we're going to go headlong into this one. I don't know what the airing times are and how that will sync with this, but just to like lay out, the foundation is an insulated composite concrete form foundation, where right off of the bat, we're able to reduce 60% of the concrete volume in the foundation system. We then took and used a 30% SCM mix, supplemental cementitious mix, in the form of a ground glass pozzolan admix, and we took another 30% of the embodied energy out of that only 30% concrete that was remaining, or 38% concrete that was remaining. So a huge carbon win right out of the gate up front. Then with Tama Architects and George Penniman, who are the design architects on the project, we looked systematically at how much foundation do we actually need, and we chose to pull foundation volumes in and put sections of the building on piers. We then said, well, why don't we just find some rocks and set the thing on rocks? And this seems crazy, but we went and found reclaimed stone locally and just had it cut to the proper pier size. And structural engineer doesn't care if it's granite or concrete. They're both perfectly adequate. And we just plop rocks into the ground and set the structure on top of that, because now it's a locally reclaimed material, and it's it's not concrete. So there's not the embodied energy coming out of it. That was done millions of years ago when the giant hurling rock formed. We then took and put its croft panels. It's a croft panelized straw insulated panel system sitting on top of it. It is an exterior insulated rigid wood fiber roof system. It's, just trying to do all the things. The interior finishes are all going to be mineral based paints and lime plasters. And we're doing Danish soap oil finishes on the floor, like really trying to pull petrochemicals out of product selections and just, try and do the right things, or at least what we think is right.
Sorry, Ilka, I feel like I'm monopolizing, but I have one other question. This is coming from, I listened to your when you spoke with Michael at, I guess, a Reimagine Buildings Collective, Ask Me Anything or Fireside Chat. I forget exactly what it was, but you talked about VOCs and how we've switched to SVOCs.
The dirty little secret, yeah.
Like, I don't know. Like, have you ever seen The Good Place, where they're like, these are organic tomatoes, and it's like, secretly these organic tomatoes were harvested in like Mexico by like a drug cartel, and it's like
under like forced labor conditions.
Yeah. And so like everything when you try to do the right thing, it just comes back and totally bites you in the ass. I didn't know about that one, and I think there might be other people who don't know. So maybe.
Yeah, so let me share that. Indoor air quality and material health is like one of my current rabbit holes of fascination. So when we made a push to have low VOCs or zero VOCs in the materials, what a lot of products and manufacturers did is they switched, right? Ultimately, what we're talking about is a solvent here, generally in the product. That's what those things are, is they're a solvent to carry some sort of material or suspension or adhesive or paint or film or finish or something like that. So they took these solvents and they took them from VOC carrying solvents in most cases to what are called SVOC solvents. So it's not a VOC, a volatile organic compound. It's a semi-volatile organic compound, which hit the criteria for this requirement of low or no VOCs. But what that did is that shifted the health impact from the installer to the people living in the place, because a volatile organic compound is one that volatilizes off out of the mixture. It evaporates, diffuses, gets absorbed out of whatever that product is very rapidly. It's volatile, right? It reacts quickly.
Yeah.
So then we switch to semi-volatile organic compounds, which means that they are less volatile and they go out of the product and into the environment at a slower rate. That slower rate is now, instead of in the measure of hours, it's in the measure of weeks to months to years. So now we took from exposing the painter to the VOCs, which he's doing better, to now the people that are living in the house all day versus the painter who's there a handful of hours for a handful of days. Those people are now getting the exposure.
Mhm.
And guess what? They might even be worse for us than the VOCs.
Yeah, I think all of this really reminds me of actually trying to read some of those declare labels or just that information that might be available to you now if you asked for it. But I did this.
Ask for HPDs, Ilka. That's what we need to be asking all of them for.
Yeah.
HPDs, health product declarations. Just like when we started asking manufacturers for environmental product declarations, did they start to come to the table with them? We now need to ask them for health product declarations because that's where we'll find all this stuff in a standardized format.
Yeah, but you also have to be able to read it, right? I mean, that's for me, I took this class one time where we looked at this project and tried to figure out, like, based on living building challenge requirements, to figure out, and compare all these available.
Is that too much benzene? Is that too much xylene? I don't know.
Yeah. And we were a big group of
Yeah.
professionals, and we had the hardest time just evaluating the information that we had. So I think besides just making that information just available, it should also be able to, be readable
digestible.
Yeah, and comparable. So I mean, I think that's the hardest thing, to really understand what you're looking at. So
it's a lot.
It is a lot. So I actually would like to go back a little bit. We started with just the progression through or evolution of the high performance building mythology that you have gone through. And I would like to know a little bit more about where, like what you have done in your career that was a little different. You talked about the double step wall, but using different materials, building those, and what you basically learned and where you kind of switched to. You just mentioned that you're building with straw panels. So what are the benefits, and what are your lessons learned?
I think the lesson learned is once I started to kind of at least have my footing in building science, it allowed me to take on different types of assemblies that other people would shy away from. And that's a reputation that I built locally, is that, if somebody had some oddball issue to deal with, and that like even went into like millwork and stuff like that, whoever had the complex problems, those were the ones that I dove into, probably foolishly. But what that's done for me, Ilka, is it's allowed me to work on a lot of different assembly types with a lot of different materials. And from that, we want this way of building to be scalable. We want it to be approachable. And I have kind of come full circle from trying to chase the hardest things to now trying to find the simplest things. Because my company's growing and this industry is growing. And we need to be able to bring people in that don't have a strong footing in building science and make these things translatable and approachable so that they can actually get built. My go-to wall assembly, I'll give you my two go-to wall and my roof assembly. My go-to wall assembly is a 2x4 double stud wall with zip system sheathing on the outside of it, because the permeance between zip system and CDX plywood doesn't actually matter. Then we put a fully ventilated rain screen on the outside of that with whatever cladding system over it. We make sure that that sheathing layer is well air sealed. And we dense pack it full of cellulose or blown wood fiber. I have a lot of monitoring data on that. That's a whole other rabbit hole that I live in, is monitoring data. And those assemblies are safe despite what the computer modeling may tell us. On top of that, then what I do is a 16-inch or 18-inch parallel cord truss, or TJI, as our roof rafter. Skin the top of that with CDX plywood, half-inch CDX plywood, which is taped to the wall like a Monopoly frame, and that becomes our air barrier up and over the lid, down to all the sides, right? Red line test. On top of that CDX plywood, we do 2x vent strips running parallel with the structural framing members, and then 1/2 inch or 5/8 zip system on top of that. And that's a vapor open, airtight, overvented roof assembly that we find performs incredibly well. It's approachable for typical framers. We find that's cost effective, and it's a resilient assembly that I know is going to last for a long time.
So you said in the computer, some of those assemblies don't work. And that was going to be my question because I know early on, I mean, that must have been a few years ago, there were definitely a lot of hydrothermal modeling of these double stud walls packed with cellulose, and especially with a sheathing, zip sheathing on the outside. I mean, I've seen it work in the computer with just a membrane on the outside, but how do you get over that misalignment basically between computer model and reality?
Great question. So this is a soapbox for me, that if you'll indulge me. Computer modeling, who is it? I think Steberg was the first one that told me this, but I know it comes from others, is all models are wrong, but some models are useful, okay? And what we all need to understand here is that computer models are built off of theoretical physics equations. Theoretical. They are our best guess at how we think the natural world works around us, turned into a math equation that we can replicate. Okay, and that's what all of those models are based off of. Some of those equations are based off of measurement. Many of them are based on people that are long dead that wrote on papyrus, and we're still using them. They are an approximation of how the natural world works. What I can share, Vitruvius was a huge one, Lord Kelvin, let's just forget it, go down a rabbit hole. What I have experienced is that those assemblies that we see the models suggest are incredibly risky. I have actually engaged in real life, long-term measurement and data collection of, and seen that there is a disconnect between the models and reality. So what that's telling me is that theoretically, the models are a good idea, but they do not correlate to reality. The way those models were designed and intended to be used as a supplement to research. So what you do is you run a set of test conditions and you get an output, and you use that real world measured output to train the model so that you can do risk analysis. We are not doing that first part of the equation right now. We are not engaging in the real world testing. And as far as I'm concerned, this is one of the greatest sins of the high performance world as we sit right now. We are building all of this stuff based on theoretical models, and nobody's measuring it. I know nobody's measuring it because I write about this and publish this, and I know of a couple of academic facilities that I have spoken with where they're like, oh yeah, we've got some data too. And guess what? We're seeing the exact same thing. Our measuring is showing that the models are off, often by a considerable margin. We need to measure more. We're building these things and we need to measure them. I wish somebody would find a way to get a grant written so that we could send people a box full of OmniSense monitors and we could have a few thousand people data collect for the next couple of years, and then we dump it into a large language model, digest it, and retune the modeling software.
Yeah. This is, I'm going to fully demonstrate my ignorance with this question. So here we go. This will be fun. What variables are kind of missing? What seems to be like
we don't know. We don't know because we're using the best math we have.
Yeah.
And ultimately what I think it comes down to is these are very complex physical things that we are building that have a tremendous amount of interaction and nuance in that interaction. And we cannot predict all of that with just basic math. Mm-hmm. Maybe we will someday, but the only way we'll get there is if we measure it to have a starting point to work from.
Yeah, no, I would totally agree with that. The problem, though, is how do we, I mean, I agree that there should be a lot more measuring, a lot more data, real world data. And I think that's, kind of soapbox for me too, the whole energy modeling and all of that as well. How is that real life? But I think it's also something that we do need, especially in the high performance world.
Yeah.
And because we have made the mistakes with sealing off, buildings and having basically mold boxes. So I feel like the hydrothermal modeling is definitely helpful to try and avoid that. And it's probably better to be a little bit more cautious than just build a lot of that. I mean, we just said,
I will
the
not
movement.
disagree with you in the slightest there. And especially as we're talking about this thing scaling and we're talking about project teams that need to do risk analysis and risk mitigation. All I'm saying is that I think those risk thresholds that we are currently using may not be indicative of what happens in the real world. And we should assess that just so that we actually know where the line is. Because we want people to do this. We want to build better. We want lower carbon. And if it's like the hydrothermal model says it's not going to work, and now you got to pay an engineer $15,000 to come in and stamp this thing, like that's a problem. That's a barrier to entry.
Yeah.
Sure.
And I'm just thinking, like the last thing you want to do is go the other, like with the UK where they had a bunch of exterior insulation installed.
It's huge issue.
Now trying to tell people, oh, we screwed up there, but now trust us, we fixed the problem. Like that's a difficulty in messaging. You're not going to get people to sign on. Like you screwed them once, they're not going to agree to it. So really
I'm afraid we're heading into that right now with electrification.
You mentioned that again, and I wanted to get your opinion. I wasn't sure exactly where you were going, and I don't know if you want to go there now. But again, this was with the talk with Michael. If you want to get on the soapbox again,
if you'll indulge me, I will. So a couple of years ago, Martin Holliday, who was the executive senior editor, whatever, of Green Building Advisor, kind of publicly took me to task over a comment he had heard me say during an interview. And that comment is that I think with all of the exterior insulation that we're putting on buildings, it's going to come back to bite us in about 20 or 25 years. And Martin said in this editorial, Mr. Bogie misunderstands how the physics of a wall assembly works. When you put exterior insulation on, the sheathing stays warmer and the drying capacity is better and da. And I wrote back the first comment after they published this, after I kind of cooled down and caught my breath after that. And I said, Martin, you missed the point of what I was getting at. And the point is we can't even get carpenters to flash windows properly on the flat. And now we're going to put this origami on the outside of the building that's going to restrict half of the drying potential of the assembly. We're already seeing it. It's already happening. Look at the UK. Australia's got a huge thing brewing right now. New Zealand's got right? Now we're going to throw the electrification in on top of it. And we're going to put in systems that are lower capacity to handle the latent humidity that's inside of the building, the latent load, right? Because the way that we're getting these high efficiency heat pumps to work is that we're lowering the compression ratio on the compressor so that the motor takes less energy to turn the compressor. And what that results in is less electricity used to operate the thing, but also the coil temperature is now warmer. So now we're getting less effective dehumidification in the space. Oh yeah, and then we're going to throw all these heat pumps in houses that haven't had the envelopes improved, and people are going to watch their electricity bill go from $400 a month to $1,400 a month, and people are going to flip out. And then in 3 years, because we have such, and I love my HVAC partners, but we have such a poor HVAC industry, a lot of these systems are going to start to break and need to be replaced or warrantied. Because we don't have the workforce that knows how to work on this level of technology. And then we're going to have the demand on the grid that's going to require us to start looking at alternative load management systems at a grid level in order to manage all of this. Like, I'm all for it, but we got to pause and slow and think a little bit here before we make a mess, and then it fully reverses because we just got handed our breakfast.
Well, is this part of what's happening in Massachusetts right now with the kind of retreat that's going on at the state level? Is that Am I reading that right? I mean, I'm down in
Yep.
North Carolina, so I don't.
Yep.
Oh, got it.
Yep. Yep.
So
Sorry,
it's kind
Ilka.
of fun. Well, I was just going to say it's kind of funny that you're talking about it because I'm actually sitting at home right now because in my office, my heat pump, my heat mini split doesn't work and it's being repaired right now.
And it
Yeah,
may have just leaked 14 pounds of R410A into the atmosphere and shot
exactly.
every improvement that you ever made on the envelope right in the foot.
Exactly. Yeah. And it's not the first time that they had to come out. Yeah.
Mhm.
Yeah.
Right?
Yeah.
It's a tough spot for us all
It
to be in.
is.
We have the best intentions, but we just need to be a little bit more pragmatic about it.
Yeah. Yeah. Yeah, it's interesting because on the one hand, I mean, everyone is pushing because we have to change things very, very quickly, right? I mean, we're up against that timeline. But on the other hand, it's, yeah, crossing fingers that we're doing it right. And obviously, things are already not going all that great. And we are missing out on all these improvements that we are trying to do. Yeah. Well, let's think about something positive. I don't want to end on this note.
Yeah.
No, it's all
So,
positive. That's what I'm saying. Like we're all headed in the right direction together. It's just we're going to stub our toes a few times, and we need to be honest about that.
Yeah.
yeah, no.
And
So
with
what? Oh, you go ahead, Jay.
I was just going back to I was working on the Hano Homes article, which was a retrofit up in Austin, Brighton, in Boston. And the assembly that you mentioned, the wall assembly that you kind of go to, sounded very similar to what they did on a retrofit of these are from 1888. They
Mhm.
the sheathing did the zip 5 inches or 5.5 inches of timber timber fiber for insulation and the cladding system. I might be missing something there, but what is that similar to your go-to for a retrofit, or do you do something very different? And is it
Oh
more
my God.
case by case?
Retrofits. It depends on the building.
Yeah.
It depends on the individual building. It's hard to give a blanket statement on any of them because, like, is it a masonry building? Like, is it
But
a
the
stucco building? Is it who knows? Yeah, how old is it? What's going on?
okay, I was hoping for something there, some type of
The-
advice because
you
that's
know, so I touched on this in last week, the Imagine Buildings or whatever it was. We need to go back to like good old fashioned weatherization practices as we look at buildings. And the first thing I care about is what's the moisture load on the building. Is the basement wet? Is there grade issues around the outside? How can we get bulk water away from this thing? That's the thing that's going to, really make a long-term impact, because I also don't want us to be short-sighted and think like, oh yeah, we're just going to super insulate all these things, but not deal with the site water, right? That's stupid, right? That site water is going to destroy that building, right? And then we're going to have to replace it. So start with that, which I know is fundamental to the passive house way of thinking and approaching buildings. But for those that aren't engaged in passive house but are interested in better buildings, that's step one. Manage the moisture, manage the water, go start at the roof, and then work your way down.
Mhm. That's great advice. That reminds me of Steve Burke. I forget what he said, deal with the fire, make sure people don't burn a line
Mhm.
inside, and then deal with your water and your different
Yeah,
containers.
life safety stuff first.
Yeah.
Always, 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 always.
So talking about like something positive, what are your goals, like immediate and further goals right now?
Um, Immediate goals is to just continue to push on all of my company's projects as hard as we can, to be the ones that sit down at the table and ask the question about the material health and ask the question about the carbon intensity of the assemblies, and continue to push that forward, because that's our own little way of, trailblazing, so to speak, and figuring things out. And then that feeds into the other thing that I'm really passionate about, which is education. And taking those lessons that we learn from the privilege of the projects that we get to work on, and trying to go out and broadly share that as much as possible, not only with builders, but also with manufacturers, because they're both sides of this industry need that information. So that's what I'm really excited about right now, is leaning into education, and there's more to come in that vein from me.
Great. Yeah, it's definitely needed. And thank you so much for doing it. I mean, I think just the fact to go out to the International Building Show and exposing or just kind of showing what's possible is huge.
Yeah, it's crazy. We have people, we're giving presentations 3 years ago about embodied carbon measurement tools. Like, to see that in that venue is incredible.
Yeah, for sure.
Yeah, well, I guess to kind of again boost the IBS, like what are some of the events that you're going to be, or not events, what are some of the subjects you're going to be talking about this year, and like what are their themes, or like
Yeah,
what you're doing for it?
and these are not gonna be any eye openers for people, but it's just like sound continuous insulation practices, sound flashing practices, things that are kind of core themes this year that we're looking at are wildfire, WUI zone assemblies and approaches and products, so that people that are in those areas, which I learned recently, about 40% of the United States is technically in a WUI zone.
Yep.
And people don't realize that. Their municipality just chooses not to enforce those codes. So talking about wildfire mitigation strategies, we're talking about air to water heat pumps is going to be a big focus right there. We're going to have Ross Trethui and Eric Awney, who are both incredible educators and experts in their field, are going to be sharing how we put these systems together, right? We're going to teach the theory as well as like, here's the parts to connect it and show how to do that so that people understand that. And then we're going to take a little bit of a dive into AI in the construction industry as it applies on a day-to-day basis, and some of the very fundamental tools that will help builders to just get the work done well on a day-to-day basis.
Cool.
Awesome.
Yeah.
Overvented roof assemblies, wall flashings, like all sorts of stuff, foundation, slab detailing, vapor barriers. Oh my, it's going to be pretty cool.
Nice. Yeah, I'm very curious about the AI stuff, because like I'm a bit of a Luddite. I like my books and I like pen and paper. I actually have pen and paper here.
Yeah.
And so I'm just, yeah, I'll be curious to see what it can do, because my first impulse is to always fear a new technology, but it seems like it could do some good.
It's in my daily professional life, I'm seeing it make a real impact on what I'm able to accomplish. And I don't want to blow too much smoke because it's incredibly hyped, and I think it is only going to do part of what everybody thinks it's going to do. But still, that part that it's going to do is going to be pretty incredible. Like my ability to, I've recently been down a rabbit hole teaching myself commercial control systems like Modbus and BACnet and BMS systems, which a year ago I would not have been able to put together the amount of information and resources and learning that I am currently able to. It wouldn't even be possible. So the rate at which I can conduct research around technical subjects, because it's pretty cut and dry around technical subjects, it does really well there. And then like simple things just in like operational and organizational tools for operating a business and a firm. I'm seeing a lot of work there that's proving fruitful.
Cool. Yeah, I've had luck. I've used it a few times for coding. Like I post all the articles on the accelerator, and sometimes it really doesn't want to do what I want it to do for layout, and I'm just like, I'm freaking lost.
I don't know how to code HTML, something.
Exactly.
Help. Yeah.
And it's just like, please help. How do I do this? And it's just like, copy and paste this, you idiot. It's like,
yeah.
Love it. So I do like that, but that's about that, and cooking, I think, are the only two things I've ever really used it for.
Cool.
Yeah. Well, I think receiving information and being able to even learn software, right? I think it's really helpful for people. Just the speed in which you can get to information, and I do think that's going to be helpful, especially for, we talked about how do you get people involved into high performance, how do they get up to speed, how do they learn. I think that's where AI can definitely take, you know, a role for
Can I
sure.
share an interesting little thing just so people have a little backstory around kind of the work that AI is doing right now in the building sphere? Um, I have seen on several occasions through Facebook, which I stay on for a technical group that's on there that I'm fond of. But when I go onto Facebook, there are all of these Facebook pages where it is an AI generated building section or construction detail that it posts. And they're clearly things that have been taken from like Fine Home Building Magazine as the feedstock into the training of the model. And they put these assembly details out on there. And there's things that are wrong, right? Clearly wrong because it doesn't understand construction. But then what happens is everybody hops into the comment box because, right, what's the old saying? You don't ask how to do something on the internet. You tell the internet how you're going to do something, and then everybody will tell you where you're wrong, right? All of these people hop into the comments and they're like, no, 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 you would never tape that there, or the insulation would never go in that location. And what they don't realize that they're doing is they're engaging in active training of the language models for construction.
That's funny.
It's fascinating. I'm a little pissed.
Yes.
Like I even saw this was like the head smack moment. I wish I took a screenshot of it. I saw one of the assemblies was clearly ripped from an illustration of a double stud article that I wrote with Fine Home Building. I'm like, that is the AI digested version of my SketchUp model right there. I didn't comment because I didn't want to beat it.
I was gonna ask what other people commented, what you did
The
wrong.
typical, the usual stuff. That's too much lumber. That's so stupid.
Yeah. Awesome. Well, I think this is probably a good time to wrap up, right?
Oh, yeah.
Thank you so much. This was super, super interesting. As usual.
My pleasure. My pleasure. Thanks for being out there and just pushing this stuff forward. And thank you for just getting it done.
And that was Ben Bogie. He's the Director of Outreach and Education and the Production Manager at BPC Green Builders, but also so much more, as you covered during that session, Jay, and also great to have Ilka there as well. So much in there. I guess the highlight for me, or the summary for me, is that that focus on what's changed, and you both commented on just how much has changed with materials and systems. And that seems to be accelerating, but also there's a lot that hasn't changed in terms of the overarching principles. And really pleased to hear a reference we don't hear about Harold Orr very much. We often refer back to Wolfgang and the first sort of passive house, but then Harold Orr, really great bit of history there with the super-insulated house, and those two things sort of happening concurrently in different parts of the world. And really interesting with Ben's family history going back to super-insulated homes, thinking about thermal bridging just as kind of a standard way of building for him, and then realizing that maybe not all people do that. So yeah, really interesting stuff, and such. Looking forward, I was really impressed with. I feel like we often don't give builders a lot of credit or enough credit for just how intelligent they are, and Ben demonstrates that with his deep thinking from everything. From electrification and the potential pitfalls of mass adoption of mini splits without thinking about the implications of moisture control, through the detailing, just so many things that he's really thought a lot about. And then of course the need for more data and how that data might be able to be analyzed and plugged back in to help calibrate models. So just an amazing amount going on in that brain, but also obviously building amazing buildings as well. So that's my summary. What did you take away?
I think one of the big takeaways was just the kind of practical advice that he gave to builders who are new to high performance, methodologies, which is just kind of focus on one element and kind of build out this bag of tricks. as you move along, which is, kind of a similar approach that I would give to a musician who's starting out. Is if you want to learn how to do improvisation, like you start to learn a few tricks. You don't try to learn everything at once, and
Yep.
because otherwise it's just going to be a mess, and you're not going to be good at anything. So get really good at one thing, then move on. And I really enjoyed that, and I think kind of going back to your point about the intelligence of builders, and I guess the willingness of builders to want to do better. And
Yep.
his description of when he's at this huge event. It's like the biggest build show in maybe the world, definitely in North America. And he's at the educational kind of center. I mean, there's hundreds, maybe even thousands of people who come and listen to him talk about this stuff. It's not as niche as it kind of can seem sometimes. There is a willingness to want to learn about it from builders and throughout the country. So I don't know. I was very pleased to hear that.
Yep.
Um, yeah.
The other thing I wrote down here was that concept of being morally defendable, and I think a lot of people, to your point about wanting to do everything and get it all right, and it is often hard to make decisions. And I quite like the idea of stepping back and saying, what's the most morally defendable position at this point in time with what's available, and that can help, I think, overcome some of those perceived or real conflicts that we have between performance and carbon and where materials have come from, and all these decisions that people are making, trying to do the right thing, and sometimes it can be a bit overwhelming. So I quite like that as a general concept of just moving forward in the right direction. So some really cool stuff. And then finally, that he mentioned about health product declarations, and I really like that, and Ilka's insights there. In it's all well and good having that, but also we need to understand how to read them, and there's a lot more that we can learn about and need to get our heads around in terms of how to make buildings healthier as we go down this path of making them perform better, but not losing sight of that goal of actually just making them healthy.
And the conversation of SBOCs remind me of I'm gonna screw this up. I probably should have written it down, but Staberbrook, it's a Staberbrook-ism, which is dilution's not the solution to indoor pollution.
Yeah.
The idea that you kind of extend the off-gassing for weeks or months is somehow going to make it better, and that's not necessarily the case. And so I think that was an interesting point, and that's another one of these things where you think you're making an improvement, but when you really kind of sit down and consider it and all the what goes along with this idea, yes, you've solved one problem, but you've introduced another one. It's kind of so these are always issues that we need to be thinking about, and it's a good reminder of that. And I don't know, I really enjoyed talking with him. And I didn't even get into beer. He did a beer show forever.
Well,
I really wanted to ask him
really
about New England beers, but
I really enjoyed listening as well. There's some great stuff in there, and so I hope that people found that interesting, as I did. Well, and thank you again to Ilka as well as yourself, Jay, for bringing us that conversation. Zach, what have we got coming up over the Accelerator and at Reimagine?
Yeah, well, and a big thank you to Ben for all the contributions he's been making at the Passive House Accelerator and in the Reimagine Buildings Collective in the last few months. We've been really lucky to have him sharing his insights at a Reimagine construction interview with Michael Ingui in the collective a couple months ago, and then just this last week, an AMA Friday in the collective with for members, and we just had Ben present at the Passive House Accelerator Live, so it's really great to be able to share Ben with our people, and I hope people enjoyed the interview today. In the Reimagine Buildings Collective, we on December 30th, we have a year-end Ask Me Anything with Ed May, which I know a lot of us in the collective are looking forward to. And so if you are itching for to get your questions answered and would like to dive in, please join us in the Reimagine Buildings Collective for that. And then Passive House Accelerator Live is taking a couple of weeks off, but then on Wednesday, January 7th, we are launching the new year, and I'm going to be presenting a version of the keynote address that I just presented at Passive House Massachusetts 2025 Passive House Symposium as a kickoff to the lives in the coming year, and then that will also launch a public challenge for 10 days about it that's built around goal setting and growth in our work as we tool up to help kind of shape the future as practitioners. So that should be a lot of fun. So please stay tuned for that. And I just hope people have some downtime and get to enjoy friends and family and some peace and quiet as we gear up for 2026.
Yeah. Awesome. All right. Well, thank you very much for that. Definitely check out all that's going on over at the Passive House Accelerator and jump into Reimagine if you haven't already. Thank you very much, Jay. Thank you to Ilka as well. Thanks all for listening, and we'll be back again next week on Passive House Podcast.